Hi everyone, welcome to the course of Generative AI and welcome back with another video. So guys, from this video itself, we'll be starting with another very important concept inside Generative AI called fine-tuning LLMs. So far we have learned about like RAG, Retrieval Augmented Generation, and there I showed you what is the use of RAG and how we can create a RAG. Okay. Even I already, I think discussed what is the difference between RAG versus fine-tuning. That means if you want to work in a domain, which is like completely new domain and you are working with very specific task, that time what you can do, instead of implementing the RAG, you can fine-tune one LLM. Okay. And to fine-tune the LLM, what you have to do, guys, you have to use one pre-trained model. On top of pre-trained model, you have to train your custom data. So let me open up my Blackboard and let me discuss there what is fine-tuning exactly. So guys, inside fine-tuning, you will be using one pre-trained model. Okay, pre-trained large language model. Okay, I think I already showed you there are so many large language models are available as open source. For this, you can go to the Hugging Face. So here you can see there are thousands of large language models are available. Now you can choose any kinds of model as per your requirement. Let's say you want to use something called Llama, Meta Llama. You can simply search Llama here. So you will get see all the Llama model. Okay, Llama 2, Llama 3, all kinds of model actually will see that. See, okay, and this is for Meta AI. Now what you can do, you can download this model. On top of that, you can fine tune your custom data. But before fine tuning, what you can do, see, first of all, let's say whatever, let's say project you want to implement. Let's say you want to implement one chatbot. Let's say you want to implement one medical chatbot. Okay, medical chatbot. First of all, use one pre-trained large language model and try to perform the inference operation. Okay, try to perform the inference operation. Inference on top of the model. If this model is able to give the correct answer, okay, if it is able to give the correct answer, try to select this model. Okay, otherwise what you can do, just try to build one RAG, Retrieval Augmented Generation. Okay, that means create a external knowledge base. External knowledge base. Then try to connect your one pre-trained large language model and try to again perform the inference operation. Okay, and try to see the accuracy of the model. Try to see like whether your model is giving able to give the correct response or not. If it is giving, try to select this model. Okay, otherwise if this both approach is not working, that time what you can do, you can perform the fine-tuning operation. Okay, fine-tuning operation. So there what you can do, you can take one pre-trained large language model from Hugging Face, from any kinds of, let's say, platform. And on top of that, you can train your custom data. The data set you are using, let's say you are using one very specific medical, okay, medical data. That time you can use this data and you can train one custom model on top of it. Okay, this is called actually fine tuning. And that should be my suggestion, guys. I mean, directly don't do the fine tuning. Before that, try to check whether pre-trained model is working or not. If pre-trained is not working, try to build the RAG based system. If it is not working, then try to do the fine tuning. Okay, because fine-tuning is a more costly task at the end, because here you need like huge amount of data, even you need lots of computational power. You need actually higher configuration machine. Okay, you should have good GPU instance in your system, otherwise you can't do the fine-tuning operation. But if you want to do the fine-tuning operation, there is some way actually we can do it, because all kinds of large language model you can see. All kinds of large language model you can see. It is having actually huge parameter size. You can see Llama 2 7B. That means it is having 7 billion parameter. It is having 8 billion parameter. That's how it is having 70 billion parameter. Just try to consider. Okay, it's a huge size model. So we can't use any kinds of low configuration machine here to fine tune. These are the model. So for this, what we can do, we can use something called PEFT technique. We can use something called PEFT. Okay, what is the full form of PEFT? Parameter efficient fine tuning. Okay, this is the full form of PEFT. So inside this PEFT, we are having some method we can use. So the first one, you can use something called LODA, or you can use something called QLODA. Okay, so this LODA and QLODA will help you to do to perform this parameter efficient fine tuning. That means it applies something called quantization technique. Quantization technique. Okay, that means it will load your model in a lower memory instance. That means it will load your model in a 4-bit precision, 8-bit precision. Okay, that's how actually it will perform the parameter efficient fine-tuning process. Now you can ask me what is quantization then. Okay, let me show you what is quantization. See, quantization is nothing but quantization. It's just a way of converting from higher format, higher memory format to a lower memory format. So this is called actually quantization. Now I think you already know about neural network, right? Let's say this is one neural network I'm having. So inside neural network, what do we have? We have lots of weights, yes or no, right? We have W1, W2, okay, and W3 and so on. So this is what actually we are having. That means we are having lots of weight and biases. Let's say B1, B2, and so on, right? Now you can represent these are the weight as a matrix, because if you know about artificial neural networks, so there I think you know how we can represent these are the weights, okay, how we can represent our input data and all. Okay, let's say this is the one 3x3 matrix I'm having, and inside that we're having lots of weights. Let's say W1, W2, W3, and so on. Okay, this is the weights, and this weight is nothing but it's a floating number. Okay, it's a floating number, it's a floating value. If you see any kinds of weight, it would be like that. Let's say 7.23000 like that. Okay, so this is called actually floating value. These are the floating value, and if you see, this floating value stores in a FP32 bit. Okay, FP32 bits. Now what is the full form of FP? FP means full precision. Okay, full precision. Okay, full precision. You can also call it as single precision. Okay, single precision. Got it? So whenever we are doing the quantization, that means what we are doing, we're just trying to convert this higher memory representation to lower memory representation. That means it is now saving these are the weights in the FP32 bits. Now what we will be doing after doing the quantization, we'll be converting these 32 bits to, let's say, 8 bits. Okay, 8 bits, or let's say 4 bits. 4 bits. That means what will happen? Let's say you are having one floating number like that. Let's say 1.70890. Now if you want to convert it to 8 bits, what you will be doing, you will just remove, these are the numbers actually. These are the numbers actually you will remove, and you will take this number only. So that's how actually you can reduce the memory size. That means you can convert any kinds of higher memory actually format to lower memory format. So this is called actually quantization. Okay, I hope it is clear. And the technique actually we usually use, let's say LODA and QLODA. Okay, QLODA. So these techniques help us to perform this quantization. That means it will load the original model as a quantized model. That means in a lower precision. Okay, let's say I want to load this model in a 4-bit precision. 4-bit precision. Okay, so let's say previously this model was in 32 bits precision, but I want to load in 4-bit precision. So how it will happen? With the help of QLODA or LODA, you can do it. Sorry, with the help of LODA and QLODA, you can perform it. We are having already some Python libraries. Okay, so we are having one library called PEFT. Okay, this is called parameter efficient fine tuning. So with the help of that, you can perform LODA and QLODA technique. So with the help of that, you can load any kinds of actual model. So these are the model. Okay, in a 4-bit precision, in a 8-bit precision. Okay, that means you can load as a quantized model so that you can perform the fine tuning operation. Because as I already told you, this actual model you can't load because it is having huge amount of size, huge amount of, let's say, weight size. Okay, and it is storing those are the weights in a 32-bit precision. And to load these are the model, we need a good configuration machine, good configuration GPU, memory, and so on. But we don't have that much of resources. We are having, let's say, Google Colab, free Google Colab, or let's say you are having a 3060 GPU. That time what you can do? That time you have to load these are the model with the help of this. These are the technique actually. The technique actually I showed you. This one, quantization. That means you will be using LODA and QLODA. With the help of that, you will be loading the model and will perform the fine tuning operation. Now you can ask me, sir, if I'm doing that one, so definitely I will lose some information. Definitely will lose some information because you are loading the model in a 8-bit and 4-bit precision from the 32 bits. That means here you are getting rid of some of the numbers. So definitely you are losing some information. But again, LODA and QLODA takes care of this part actually. So they try to optimize your, let's say, model weights as much they can. Okay, so you don't need to worry about if you're using these are the library. everything would be happen in an optimized way. So we'll be learning as a practical also how we can fine tune one large language model. So in the next video, we'll be learning how we can fine tune one model called Llama 2, Meta Llama 2. Okay, we'll be fine tuning this model on top of our custom data. And here we'll be using this PEFT technique, parameter efficient fine tuning technique. Got it? Because I'll be using free collab here. If you want to do in your local machine, if you are having, let's say, any basic GPU, you can also do it. But I'll try to train on Google Colab if you're not having any kinds of GPU, okay, and not having any kinds of good configuration machine, you can perform on Google Colab. Fine. So yes, guys, this is the introduction of fine tuning, and I think you got to know how we can perform the fine tuning operation and what is this PEFT, okay, PEFT technique exactly, and what is LoRa and QLoRa, because I know that many people will have this question, what is QLoRa, LoRa, and what is PEFT and all. Okay, so I think now everything is clear, okay, how things are working here. Fine. So in the next video, we'll see the practical demo of the fine tuning. So we'll be fine tuning one model, large language model called Meta Llama 2. With that, guys, thank you so much for watching this video, and I will see you next time.